Hello guys, and welcome to today's chemistry class for S.S.1. In today's lesson, we will be taking the particulate nature of matter, but the part 2 of it. Now, each orbital has a maximum number of electrons that it can hold. The sublevel S has a maximum of 2 electrons, while the sublevel P has a maximum of 6 electrons. The sublevel D can carry a maximum of 10 electrons, while the sublevel F has a maximum of 14 electrons. Lesson objectives. By the end of the lesson, the student should be able to explain orbital, define a shell, explain the 4 quantum numbers, Alright, let's proceed. What is an orbital? An orbital is a region or space where the probability of finding an electron is high. While a shell is an imaginary line on which electrons revolve. Each shell is divided into orbitals. These orbitals are called S, P, D, and F orbitals. Each shell contains its orbitals, e.g., the K shell contains only S orbital, while the L shell contains the S and P orbitals. The M shell contains S, P, and D orbitals, while the N shell contains S, P, D, and F orbitals. Now, each orbital has a maximum number of electrons that it can hold. The sublevel S has a maximum of 2 electrons, while the sublevel P has a maximum of 6 electrons. The sublevel D can carry a maximum of 10 electrons, while the sublevel F has a maximum of 14 electrons. So now let's take a look at this table where we have 3 columns: the shell, shell number, and orbital types. The K shell has shell number 1 with orbital type 1s. The L shell has shell number 2 with orbital types 2s and 2p. The M shell has shell number 3 with orbital types 3s, 3p, and 3d. The N shell has shell number 4 with orbital types 4s, 4p, 4d, and 4f. The sequence of filling up these orbitals with electrons is as follows: 1s, 2s, 2p, 3s, 3p, 4s, 3d, etc. And the reason for filling them in this order is to obey Avbau's principle, which says that the orbitals should be filled from the lower energy orbitals going up to the higher energy orbitals. So anyone we fill before the other simply means that one is of a lower energy, e.g., 1s is of a lower energy compared to 2s, and 2s is of a lower energy compared to 2p, etc. Let's now take a look at the quantum numbers. Each electron in an atom is described by 4 different quantum numbers. The first one is the principal quantum number, which is usually represented by small letter n. The next one is the azimuthal quantum number, also called the subsidiary quantum number. It is usually represented by small letter L. The next one is the magnetic quantum number, which is usually represented by small letter m. And then we have the spin quantum number, which is represented by small letter s. The principal quantum number specifies the shell that an electron belongs to. It is represented by n and has values ranging from 1 to infinity. The maximum number of electrons that can be in a shell is described by the formula 2n squared. So now, let's take a look at the subsidiary or azimuthal quantum number, which is represented by L. It normally tells us the number of subshells in a shell. It has values ranging from 0 to n-1. So, for shell 1, n is equal to 1. That is, the number of subshells will be from 0 to 1-1, i.e. from 0 to 0, which is 0. For shell 2, it will be n is equal to 2. The number of subshells will be from 0 to 2-1, which is from 0 to 1, which is 1. And for the third shell, n is equal to 3, so that the number of subshells will be from 0 to 3-1, i.e. from 0 to 2, which is 2. And for shell 4, it will be n is equal to 4, that is, the number of subshells will be from 0 to 4-1, that is, from 0 to 3, which is 3. Going forward, the magnetic quantum number is represented by m. It indicates the number of orbitals in a subshell. So remember, we have a shell, which is indicated by the principal quantum number. Then we have subshell, which is indicated by the azimuthal quantum number. Then now I'm talking of the orbitals in the subshell, which is represented by the magnetic quantum number. It has values ranging from -L to +L. So you check the L values, which we calculated under the azimuthal quantum number. That is, for shell 1, m values will be from -0 to +0, which is 0. For shell 2, m values will be -1, 0, and +1. That is 3 orbitals. For shell 3, the m values will be -2, -1, 0, +1, +2. That is 5 orbitals. For shell 4, m values will be -3, -2, -1, 0, +1, +2, +3, meaning 7 orbitals. Now, from the foregoing, you would see that the first shell that has just the shell, no subshell, can contain only 2 electrons. The second shell that has 3 orbitals can contain 6 electrons, 2 in each, while the third shell can contain up to 10 electrons, meaning 2 electrons in each of the 5 orbitals. And for the fourth shell, which has 7 orbitals, when each of them contains 2 electrons, you have a total of 14 electrons, which is the maximum number of electrons that that orbital can carry. Next is the spin quantum number. It is represented by S, and it indicates the direction that an electron will spin. It has only 2 values, -½ and +½ Summary. In this lesson, we learned about the orbital, the shell, and then the 4 quantum numbers. So, we have reached that part where we'll assess you to see how far you have learned. Question 1. Which quantum number tells us the number of subshells in a shell? A. Shell quantum number. B. Azimuthal quantum number. C. Magnetic quantum number. D. Orbital quantum number. Question 2. A region of space around where an electron is most likely to be found is called A. A shell. B. Quantum number. C. Atom. D. Orbital. Question 3. How many quantum numbers are there? A. 1. B. 2. C. 3. D. 4. And so with this, we have come to the end of this class. Thanks for watching and see you in the next lesson.